Well, hello good people of the internet. So today I want to continue, it's not a channel-y thing, but today we're going to be looking at actually downloading stuff offline to use in your program. What I actually want to do, and I'll quickly show you, I've got a list here. So the folder I'm working in has two things. It has geokey.go, which is a key that I've downloaded. I'm not going to show you what that is. It's just a constant declaration of the key, which will be a string. And in here is gtest.go, which has the data in which I want. So I have this list of addresses, and what I'm going to want to do to create is a program that looks up on Google what the appropriate longitude and latitude are for this list of addresses. Now some of these addresses are legit addresses and some of these addresses aren't. I don't even care. I just throw out a few postcodes. I was expecting that maybe I'd have a much longer list than this, but this works, so I'm happy. I've got a list of addresses and I'm going to ask Google what is in those addresses, or what location they point to. So to get started, I'm going to also create a new file, which is my main getter.go. Oh, I got the package wrong on that. So that should actually be, I'm working in a folder called getter. Obviously I've already done a practice, and the practice was called latlongs. So package getter. Now we're going to need our actual get method, and I'm going to do this like a HTTP kind of get. So it's just going to, we send out the get, we get back a request. So we'll make a func which does get, capital G, because we'll be able to use this outside the package, and it will take a URL, which is a string, obviously, and then it will take args, which will also be string, but these will be, we'll have a bunch of those args. My theory is it will save us a bit of work in some places. So we'll take the URL. The first thing we need is a request, right? http.new request, I think it's called. URL. And what does new request require? http new request golang. I thought I knew this and I'd got it sorted, but we'll see. There we go, new request. You got to tell it it's get, you got to give it the URL, and you got to, there's one nil thing. So get URL and nil. Rec dot. We'll do oh, what's missing here? I remember that colon equals. I think there's an error that can come in here. It's probably a parse error. If error does not equal nil, return errors dot wrap. This is Dave Cheney's library I'm going to use, which is basically quite a nice way of handling errors. I'll link to his talk on how to use it. But basically, could not pass URL, could not use URL. We work with that. Oh, and it's supposed to return, this function should return, I reckon, a byte array and an error. That makes sense, doesn't it? So we should probably return an empty byte array. So first things first, we make our request. The next thing we do is we'll add the arguments to it. So q colon equals rec dot URL dot query. Yeah. And once we've got the query, we can add our arguments. So I'm going to do this in a for loop. For I colon equals 0, I is less than len args -1, because I want to do it in pairs, and I plus equals 2. So I'm going to work through them in pairs from the args list and add them like so. So q.add, and we can just add args at I, args at I plus 1, and now our query will have the appropriate things. And now the last thing we need to do is actually pass that query into our request. So it's rec.raw something. No. Oop, that wasn't what I wanted. I know, it's URL. url.controlxo, and we should be able to find in here is raw query equals q dot encode. So that's a little bit of a weird thing. I'm pretty sure that's correct though. So basically I've gone through the list of arguments and I've put them in pairs, and I've let the query encode them directly, so any ands or question marks will probably be sorted out in there. Once we've done that, we need our client, and I'm just going to use http.client. It's important when you do a client to set its timeout, because if you don't set a timeout, obviously you're just creating a struct, it's going to default to 0. We don't want it to default to 0, so I'm just going to set it to 10 seconds, 10 times time.second, because obviously it takes a duration as its type, isn't it? And oh, don't forget the comma on the end. I'm sure that will complain anyway. And then I'm pretty sure we just call, oh, we need a client. Client colon equals, and then we should get a response and an error if we call client.do and we send it our request. Now, that response has some properties. If we look, response dot, we've got several things in here, but for me the most important part is the body. We'll treat the body, it's a read closer, so we can get stuff and we can close it. Perfect. So that ought to be our response, yeah? So if error does not equal nil, as usual, return bytes along with errors.wrap error and could not load thing. Could not load. Could not get response. That's probably the clearest way of writing that. And remember that wrap thing, I should show you where its library is. I'll show you here. It's github.com/package/errors. That's Dave Cheney's library on the subject. He seems to be someone who knows what he's talking about when it comes to Golang. If you've not seen his name on a few of the things that are fairly significant there. I don't know exactly what his job is. I think it's related directly to Golang. So, next question. Officially, we should have this response, right? So why don't we use ioutil.readAll, and we just send it response.body, yeah? Now, I have a feeling does it return any errors? I don't think it needs to return errors, does it? So IOUtil res colon equals util.response body. Oh, and we need to close it, don't we? This reader. So resp.body.close, and we'll put that in a defer, and I guess we can return res nil. We just check IOUtil doesn't let's try and build this and see if there's any problem. Ah, no, that's better. Read all returns an error. That was the problem. So if we come back here, so we will have an error, and if error, you know what? Why don't we just if it returns a byte array and an error, we can just return it directly, can't we? Matches our needs. So it's built. So our function technically works. Obviously we need a test to see that this is doing what it wants, but let's just run through the function and see, describe what I think it does. First, we make our request using the URL. We tell it it's a GET request, which is a string required. And if there's a problem with that, we throw an error. And then we make our query up by adding all of the arguments, and then we set the request's raw query to be the encoded version of this. Then we make our client make sure to give it a timeout, and we call its do method. Now I'm pretty sure the do method ends up calling a go function in there, and we have to wait for that to happen. So because that takes time, we'll need to be careful, and we use some stuff with that later. But in theory, this does a whole ton of stuff. So if we just want to test that we can get something from this, let's start a function. Func, capital T, test, get. And for now, T pointed to testing.t, get http://www.google.co. And we'll just print the result. I know it's not ideal testing habit, but honestly I just want to see that we're getting a result. So for I colon equals, no, not that, s comma error colon. So this if error does not equal nil, will fail the test. For t dot fail t dot log error. That'll probably work. Otherwise, I'm going to do front.print print line string on s, because it should be a byte array. We want to see it as a string. So in theory, if I run go test -v, we should see the response as a load of HTML or Java. There's a ton of JavaScript in there too. So yeah, that's basically Google's web page as HTML. So it works. Good. That's our first stage. The next thing I want to do is I'm actually going to be using a very specific API. I'll show you what it looks like. Here is the web page. It developers Google Maps documentation geocoding start. Okay, and that's where you can look this information up. Sample response request. So basically what you're going to do is you're going to send this HTTPS request with an address and your key, and it should return a JSON file with all of the information about that location. Okay, now to get a key you need to actually click somewhere and get that key. I already have that key, and that's what's hidden in that Go key file, a geokey.go file, and you're expecting a response that looks something like this, which is quite deep really, but in there is a longitude and latitude result that we can use for doing maths and things. So the first thing we need to do obviously is call our get with the correct API. So we'll make our new function, which is called func get lat long, and this will take a URL. No, it doesn't. It's going to take an address, and it's going to take, no, that's all it needs to take, and it will return a lat long and an error. Wait a minute, I hear you say, what's a lat long? Well, I'll tell you, it's a type and because we're going to be doing some JSON on it, so lat float 64, and we'll give it a JSON of if you were paying attention, you'd have seen the that they were called lat and long float 64, and this is a JSON of LNG. Okay, so that's back from our website where we get our response. They are called lat and lung. So that's the type that we're going to return, or an error. Makes sense, doesn't it? So the first thing we need to do is b, error, colon equals get, and the URL is, where'd you go? All of this up to here. Copy, paste, and then the arguments, we're going to send address of A, and key is geokey, which again is that variable I declared and haven't shown you. So if you wanted to use this library, you'll need to put your own one in. I've just made it in a git ignore. It's not quite the best way. Probably the best way is to have a file, but it was so much, it just felt easier. So we have this body request. So in theory, the body is JSON. Now what I'm going to do is I'm going to use another library called gjson to find the lat long part of the JSON file. So jrec, oh, we need to check on the error, don't we? If error does not equal nil, return lat long and errors dot wrap, and we'll wrap the error with could not load from load address data. Otherwise, we will do this. JRes, that's JResponse. No, never mind. Something. Is gjson dot, and the method we're going to use is just called get. I really like this library. It's really fairly basic. Now let's take a look at a classic sample JSON. So it starts with results, and then the next thing we want to find, oh, you've got to be careful here because results is then an array of maps. So it's results dot 0 dot geometry dot location. So this is easier than creating I was going to create a set of structs, a slightly complicated one. Each struct contains its appropriate part and then pass the whole thing. But all I want is the location. And gjson.get, which you can, well, we'll find out when I hit save. We should find out where you can get it from. There you go, github.com tibwall gjson. Great little library. That actually returns something called a result. It's a gjson.result, and that result has several options, including a raw. So if we do gj. You've got a couple of options here. They're all mostly functions, but there's a couple of options, including a raw, which is the string you had, which is just that location. So now I can do normal JSON, JSON.marshall, and I need to have a location, res location. Know what to do it. Marshall we'll do a wiggle down byte, and actually because it's gj.raw is actually a string, which I find a little bit weird because I feel like if I'm going to work with it using the other JSON stuff, bytes makes more sense. And obviously we put that into res. And this can return an error, can't it? Error, colon, not colon, equals. So if error does not equal nil, return error. No, return. Well, we'll return res and error, so people can grab whatever came out of it, but the important thing is, oh, it's not error, it's error. And the last stage, otherwise we return res, and that should be a latlong. Yeah? So if we go edit our test, to get latlong, and we'll just give it an address. Well, right, so here's an address, and this ought to work except for this string bit. And if this does work, we should end up with a latlong. So 24, not enough arguments in call to gjson.get. Oh yeah, because gjson, obviously it needs the JSON string to work with. We'll try that. 24, can I use b type byte array as string? Oh yeah. I really think it should be working with byte arrays. 25, undefined location. Oh. Latlong. 32, not enough arguments to return. Oh, oops. Unmarshall non-pointer getter. Oh, well, that was silly, because of course that's got to be a pointer. And here we go, we've got a latitude and a longitude out. So now we have a function that can get a longitude and a longitude. So now we have a function that can get a latitude and a longitude from a list, from the array. So in our test method, now what I want to do is for a colon equals I comma a colon equals range addrs, we are now going to get all of them, right? Lox colon equals a slice of string. In fact, let's make one. Make string, and we'll give it length of addrs. Right, so. And here we can do lox at I colon equals get addrs. Oh. L comma r colon equals get lat long a, and lox I equals L if error does not equal nil. We'll print something t.log error. Okay. No new variable. Oh, yeah, obviously you can't do that. And so we don't need that anymore. Now we'll print out lox and see what we get, but that should actually be quite cool. Lox. And okay, this can't fail the test, but if we run the test, let's see what we get. Cannot use L type lat long as type string in assignment. Oh, yeah, of course. So now it should be running every single one of the tests. And we've got a ton of them have worked. Some of them have come back as zeros because they're not real addresses, but they have all worked. It took a little while, and I think we can do this so that it's better using the work groups that I created last episode. So in fact, this was the entire reason I did the work groups, was because I wanted to do this more effectively. So if we come back here, and in our test instead we use workers.new, and we'll make 10 workers, and we'll call it WG. So now we've got this list of workers. If you're curious how this worked, this is created last week, so you should be able to see a nice little thing. And now basically it's going to run this function, so I'm going to make a function do get colon equals func, and this takes an a and an I, a string I int, and this returns a func. And you have to kind of, because the work group, the workers, just runs a single function, I'm making sure that this function is a single function, but I want to send it these parameters. And the reason I'm sending it these parameters is because if I don't send those parameters to the function, they will change as the loop changes while the go func is happening. So if I send them as parameters, that locks them in as what they are. And this function will do basically everything that's in here. And in this loop now we just call do get of I of a comma I. And the same thing should happen as before. Nothing should happen, of course, because WG also needs a wait called, and this is wrong because this returns a function, so we do WG.add. So this is our working group, so it starts a ton of worker functions here, and then we add the functions that we want it to do, and it will start them immediately as soon as it gets them, but it can only do up to 10 at a time. And then when we hit wait, we wait for every single one of those things that we've added to be completed so that we can move on and print them all out. So now if we run this test, too many arguments to return. gtest31. Oh yeah. This obviously returns a function, so we need to do that. And there you go, that was significantly quicker because it was running 10 of them at the same time. And I'm going to call it there. So hopefully do take a look and see. I'll put a link in the description to how I did the workers group. I'll also put a link to Dave Cheney's thing. And other than that, see you next time.